What's up guys, it's Brad from Light Architect here. In this video, I'm going to show you how you can create some gasoline style explosions inside of Blender utilizing the KHAOS add-on and a Mantaflow simulation. This technique is fairly simple and can allow you to get some fiery explosions for your 3D animations or even live action composites. Now I'm going to be using Blender 2.93.6, but keep in mind that depending on which version of Blender you are using, Mantaflow sometimes for whatever reason gives slightly different results, so you may have to adjust a bit of your settings. For simulation in general, whether you're using Blender, 3ds Max, Maya, Houdini, most of the time you're going to have to experiment a bit to get the desired result that you want. You can get some really awesome and surprising results sometimes, but sometimes you get a result that you don't want and you have to tweak the simulation settings, which is a normal part of the simulation process. Anyways guys, let's get started. Here we are inside of Blender. The first thing I'm going to do is just delete everything in our scene here. And I'm going to go here to the Render Properties tab and just switch the render engine over to Cycles. And I want to go here to Film. I'm going to turn the transparent option on so we can render this with an alpha channel later. And then I also want to go to the World Properties tab here. I'm going to go ahead and choose an environment texture and then load up an HDRI for some environmental lighting. And this is just so we can set up the lighting of our scene a bit so we can actually see our explosion a bit once we start adding some operators and simulating stuff. Another thing you want to do is under the Render Properties tab here, under the Light Paths option, just increase your volume bounces a bit. I recommend at least 2, but I'm going to use 4 for the sake of this tutorial. And what this is going to do is it's going to allow light to bounce around the smoke and fire, which is going to give a nicer looking result for your final render. And you can just see the detail within the simulation quite a bit better when you do this. Alright, so now let's build our fuel field for our explosion. So we'll go over here to the KHAOS tab, and as you can see here, we have our main panel here for KHAOS, which is what we're going to be using today. But down here at the bottom, you'll notice that we also have our KHAOS destruction tools, which we have just released, which allow you to fracture and destroy 3D objects with various debris and constraints and stuff like that for a more realistic result. But anyways, we're just going to be using this top portion for this specific tutorial. I'm going to first go ahead and scroll down here and add a collision cube, and this is just going to be the base of our explosion. So we have kind of just a base layer for our particles and smoke to interact with. And now I'm going to choose on our timeline where we want our explosion to start. So I'm going to say about frame 20 here. And I'm going to scroll up here to KHAOS particle parameters. And we're going to change a few of these initial particle parameters here. I'm going to make the initial starting velocity and initial ending velocity at both, I'm going to say maybe 10. And in later versions of Mantaflow, for whatever reason, I found that we have to crank these up a bit. I recommend you try at least 5 or 10 to start out. If you're creating some kind of burning debris kind of particle trails, I recommend bringing this down back to 1. But for the gasoline part of our explosion, we're going to keep it at 10, so it's a little bit more of a violent blast. So what this parameter is doing is it's actually making the smoke that's being emitted from the particles have a initial starting velocity 10 times as fast as the particle is moving. So I do recommend you increase this, and you can play around with different results, but I'm going to keep both of these at 10 for now. And I'll scroll up here and I'm going to select the dynamic smoke fire checkbox for this example. And we're going to be using a variety of operators to build our explosion fuel field, but I'm going to start off with the omnidirectional burst here. So I'll go ahead and select that. And now as you can see here, we have a fuel particle emitter as well as a smoke domain here, which contains our KHAOS fire shader as well as some basic domain settings to get you started with your explosion creation process. Now you'll notice that there's a little fire here in our smoke domain, and that's because we simulated another explosion earlier today. And for some reason, Blender is finding some of that smoke domain data and adding it to this domain cube as well. So it's just a small error that Blender is making. To resolve it, I'm just going to go to our physics properties tab here with our smoke domain selected, click on bake data, and then press escape really quick. And then I'll click on free. And now as you can see here, we're reset back to a very basic domain cube. All right, so I will select our domain cube and just move it up here to the base of our ground plane. Maybe just scale it up a bit as well. This domain cube is going to surround your simulation. So you want it as small as possible to retain the detail in your simulation for the given resolution divisions, but you don't want it so small that the simulation intersects with the edges of it. So as you can see here, if I scroll through our shot, you'll see our particles emitting from our omnidirectional burst here, and they're getting pretty close to our smoke domain here, so I might have to increase the size a little bit. But first I'll select our omnidirectional fuel field here and adjust a few of its particle settings. So I'll go to the particle tab here and I'll scroll down here to velocity. I'm just going to bring down the normal velocity to say 16, and I'll bring down the randomized to say 6, and I'll play through the scene again. Alright, so that's looking a little bit nicer. Another cool thing we can do here is kind of scale the omnidirectional burst in different ways. So you can see if we scale this on the z-axis, you'll notice that it's going to blast particles more upward along where the geometry is stretched toward. So this is a nice way you can kind of shape the fuel fields of your explosion. I'm going to actually bring it down on the z-axis, so it's just kind of like a base of our explosion. Give it a little bit of random shape. You can also bring this into sculpt mode and, you know, give it some really random variation, but this should be just fine for our example. We're going to add some detail to it with some other operators. All right, so something like this is pretty good. I'm going to increase the number of particles to say 200. I'll keep the lifetime at 4. For our viewport display, I'm going to change this to circle so we can just kind of see our particles in a different way. This doesn't affect the simulation itself, but when I'm building my fuel fields, I like to kind of see what my particles are doing in a little bit different way. So you can change this to circle, or cross is another good one. So what we want to do is we want to just create some dense bits of fuel, so that'll turn into some fiery explosiveness. And I think this is going to look pretty good. I might bring down the normal velocity to maybe 12 instead, so just a little bit less. So something like this is probably pretty solid. So it's just a very short burst of fuel. So this is pretty solid, and we could bake this out, but we want to add a little bit more random variation to our explosion to give it a little bit more of a custom result. So I'm going to go back to frame 20 here. In fact, I might go to frame 21 or 22 so we can add a secondary kind of blast to our fuel field. And I'm going to keep the dynamic smoke fire selected in our KHAOS tab here, and I'm going to click on the 360 ground burst option. And this is kind of a directional particle emitter. You'll see it's kind of a cone shape here, and when we play it, it's just going to blast out like you would expect. And the cool thing about this one, as I mentioned in previous videos, is you can kind of scale it up or down on the z-axis and have a very directional, you know, particle system for your fuel field. I'm going to change this in the viewport display to maybe cross, so we can kind of differentiate the two here. And I'm just going to kind of place this as a secondary blast coming from our explosion. I don't want it moving quite this quickly, so I'll go to our normal velocity here, bring it back down to probably about 12, and bring the randomize down to 6. So now we kind of have some variation in our fuel field, which will be pretty cool. So we can kind of maybe rotate this around here. And this is where you can kind of have fun with it. Where do you want the fuel to be most concentrated and have the most part of the flames and everything? So I think this will be a nice secondary blast here. I might increase the number of particles to maybe 170. You could increase it way more, but just kind of up to experimentation here. So yeah, this will be a nice secondary blast. I might press Shift D with this one selected, duplicate this fuel field, then duplicate the particle settings, and now I'll rotate this in another direction, scale a little bit up on the Z axis, maybe change the frame start to 25. And you'll see again we have a little bit of a secondary blast there as well. So this is where you can kind of have some fun with it depending on how you want your fuel field to look. I think this is going to look pretty nice though. I might add one more fuel field. I might select our omnidirectional fuel field and duplicate it. So press Shift D, then I'll duplicate the particle settings over here, and then I'll just rotate this omnidirectional particle system here so it's blasting straight upward. Give it a little bit of variation, have some fun with it. Something like this is probably pretty good. And we'll play through it once more. Awesome. You might have to experiment with this on your own, but I think that's going to look pretty cool. So now let's go ahead and set up our domain to bake our simulation. Actually, first I want to add a area light to light up our smoke in addition to our HDRI. So I'll press Shift A. I'll add a light area. Just kind of put this off to the side here, scale it up, and hit our smoke from one side and increase the power of our light to maybe, we'll try 2000. Then I'll duplicate this lamp, put it on the other side. You can do 3-point lighting if you want, but I found that 2 sources tends to look pretty nice. So something like this is pretty solid, I think. We can adjust this later. Now what we want to do is we want to set up our domain cube and kind of do a little test bake to see what our simulation is going to look like. So I'll select our smoke domain here. I'll go to our physics properties tab, and there are a few things we can adjust here. The first one, as I mentioned in previous tutorials, is the resolution divisions. And this is one of the main settings you want to change depending on how you want your simulation to look. So essentially, the higher this number is, the more voxels this domain cube is going to be divided into. So it's going to give you more detail the higher this is, but it will also give you a different look. The cool thing is, depending on the look you want, even if you have a low resolution divisions and not a lot of resolution in your simulation, if you like the general shape of your simulation, what you do is you scroll down here to the noise option, and then you up-res your original simulation with smaller scale detail to keep the original shape but add some more resolution on top of it. So what I recommend you do is start off with low resolution divisions, bake your simulation, see what it looks like, try a few more bakes at different resolution divisions, a little bit higher, a little bit lower, depending on the look you like. And once you get a general simulation look that you like, you can experiment with some turbulence fields, kind of add a little bit of random variation to it. And then finally, once you get the shape you want with the resolution divisions you have, you scroll down here, you're going to check your noise checkbox, and depending on how much you want to up-res your simulation, you can up-res it right here. But I'll get into that later in the tutorial. I'm going to just scroll up here. I'm going to keep the resolution divisions at 128 for now. I think that's going to be pretty solid for our simulation. I want to go here to our cache tab, and this is where we need to save our simulation data. I'm going to change our end frame for our simulation to be maybe 130, just over 4 seconds. And I'll click on the output checkbox to choose where we want to save the simulation data. And I'll just create a folder, gasoline explosion cache, select that, accept. And I actually need to save our project first. So I'm going to go ahead and go to File, Save As, and find this folder, gasoline explosion tutorial. And I'll say gasoline explosion tutorial. All right, so save it there. And yeah, make sure your cache is still where you want it. And yeah, now we can adjust our domain settings and give it a test bake. First, I'll go here to our fire properties. And for a gasoline style explosion, I do want the flames to linger a bit. So I'm going to bring down the reaction speed to maybe 0.06. If you have a lot more particles than I have, I only have about 100 or 200 particles on each of our fuel fields. But if you have, say, maybe 1,000 particles on each of these, you're going to want a little bit higher reaction speed for the same style of result. So just keep that in mind. The amount of particles in your fuel systems and your reaction speeds are going to be kind of inversely related for the same result. But anyways, I'm going to do 0.06 reaction speed. That should be pretty good. I think that's all I'm going to change. Most of the domain settings in the smoke domain that KHAOS imports for you are going to be pretty solid. And now I'm going to check the adaptive domain checkbox for testing. I don't recommend you use adaptive domain for your final result, but for testing, it speeds up the process quite a bit. So I recommend you test with adaptive domain, and then when you're trying to do your final bakes, deselect that. But yeah, I'll go ahead and select that, and now I'll click on Bake Data, and we'll give Blender some time to simulate our original explosion base mesh. Alright, so right off the bat, this is our explosion result, and you'll notice that it's pretty low resolution right now, but it's actually not bad as far as the shape goes. You know, you have your initial blast here, and then it's just kind of going up off into the sky, and I'm actually liking the general shape. The only thing that's creating that shape right now is just the way the fuel fields are blasting and each individual particle, etc. But this is not a bad result for the first time. I do want to break up the smoke a little bit with some turbulence, however. So what I like to do is add two different turbulence fields to give two different levels of detail on top of this mesh. For the sake of this tutorial, I'm going to assume we like the general shape of our explosion here, and now we're going to just kind of add a little bit more turbulence to give it a little bit more of a distinct look. So I'll go ahead and free the data here. Go ahead and press Shift A, and I'll add a force field turbulence, and this is just going to add some noise force field on top of our simulation here. So I'm going to go to our physics properties tab here, and I want to adjust the size of our noise. Now, this can be a little bit confusing, but the best way I can describe this, I think, is by increasing this to 1, for example. I'm noticing that the noise is about the size of one of our grid lines here. So in my experimentation, that's a good way to kind of judge how much this size is going to affect your simulation. So it's going to break up and vary your smoke in a noise pattern that kind of breaks up the smoke in little squares of just, you know, one grid here. So for the large scale detail, I'm going to have the size here about 1. And what I want to do is I want to keyframe the strength of this turbulence field. So at frame, say frame maybe 22, about when our fuel fields are starting to emit, I want to have the strength maybe, you know, pretty high. I'm going to try actually maybe 1000. That's pretty significantly high. If you already like the general shape of your simulation, you don't have to go this far, but I'm just going to kind of use this as an example. And I'll hold my cursor over the strength value and press I to add a keyframe there. And then I'll go a few frames forward here on our timeline to where the simulation has burnt out a bit. And then I'll bring this back down to 0. And then I'll hold my cursor over the strength again and press I to add a keyframe. and you'll see we have the strength of our turbulence animated, which is going to just break up our smoke in a nice way. So I'm going to leave this right here. You could actually animate the movement of your turbulence field over time to give even more variation, but I found that this is going to work pretty well. Now what I want to do is I want to add another layer of turbulence for even smaller scale detail. So while our first turbulence field is selected here, I'm going to press Shift D and duplicate it, and then I'm just going to make the size of this turbulence field something like maybe 0.2. And that's going to just give smaller scale detail on top of our smoke. I also might want to change the keyframes of our strength for the small scale detail, and I'll keep it at 1000 for the start, but I want to also have this noise linger a bit. So I'm going to drag this last keyframe, that's the strength value of 0, a little bit over, a tiny bit more. So it kind of affects the simulation a little bit later into the scene. So something like this might be pretty good. And again, we can animate those if you want more variation in the noise pattern, but I think this is going to look pretty solid. So I'll select our domain cube again, and we're going to do another test bake with adaptive domain on just for the sake of this tutorial. So I'll go ahead and click on bake data, and let's see what we get with these turbulence fields. Alright guys, so our second test simulation turned out pretty nice here. However, that initial large-scale turbulence field definitely changed the general shape of our explosion quite a bit. However, I think this could be a pretty good thing. We can go ahead and just kind of scroll through our simulation here. You'll notice that we have both large and small scale detail in this explosion. The one thing I'm seeing here that I don't really like is eventually, as you can see when we get further into the simulation, we're getting a little bit of clipping on the edge of our domain cube, and that's just because our domain cube isn't quite big enough. But as far as the actual look of the simulation, I think this is going to look like a pretty nice looking large scale gasoline explosion. Now obviously there's not enough detail in it yet, but we're going to solve that all with the addition of some small scale noise here and the up-res factor. So I'm going to say this is a pretty nice result. Of course we can give it a quick view using our viewport render animation option so we can kind of see it play back in real time. So I'll just bring down the resolution here to 60% for the sake of this, and I'll go to our timeline here, set this from 1 to 130 since that's when our simulation occurs, and then I'll go to view and viewport render animation, and Blender's going to go through all of our frames in preview mode and kind of render them out, and then we can play them back in real time. Alright, so I'll go ahead and close our window here, and then we can just go to render and view animation, and we can see it play back in real time. And yeah, I think that's looking pretty awesome. That initial blast is turning into something really cool. Alright, cool. So I'm going to just rebake this without our domain clipping the edge of our smoke simulation here, and then we'll bake our high resolution noise. So I'll select our domain cube here, I'll go to our fluid settings, and I'll free the data, and then our domain was clipping a little bit, so what I'm going to do is I'm just going to scale up our domain cube a tiny bit, maybe 1.2, okay? And because we scaled up our domain cube, we also want to increase our resolutions times 1.2 as well. So I'll just kind of multiply this times 1.2. We got about 154. So that should be pretty good to compensate for our increase in our domain cube. And yeah, now I will deselect adaptive domain for our final bake here. I'll go ahead and save our project. And now I'll click on bake data, and once again we'll give our computer a little bit longer this time since we're not using adaptive domain, and we'll give it some time to bake our original simulation so we can finally bake that high resolution noise on top of it in the next step. Alright guys, we are back, and we have baked our original explosion base mesh for our simulation without the adaptive domain, and as you can see here, later in the simulation our domain cube isn't cutting off our smoke anymore, so now it's time to add some high resolution noise on top of our simulation to give it enough resolution so that we can render it with lots of fiery and smoky detail. First, I'll go ahead and save our project in case we get any crashes or anything, and then I'll select our domain cube. I'll go back to our domain settings, and I'll scroll down here to our noise checkbox. I'll go ahead and select the noise checkbox as well, and now it's time to choose how much we want to up-res our smoke by. Now, depending on how much detail your original smoke simulation mesh has, you can increase or decrease your up-res factor. For the sake of this tutorial, we only have 154 resolution divisions, which is not a lot, so I'm actually going to increase the up-res factor to maybe, I'm going to say 4. 3 might be pretty good, but I like to go for a little bit more of a photorealistic look, so I think 4 should get us there, and I'll click on bake noise, and once again we're going to give Blender some time to bake this noise on top of our original simulation base mesh to get that fiery detail. Alright guys, we have baked our high resolution noise on top of our original simulation base mesh here, and now it's time to do a bit of shading on our simulation utilizing the KHAOS Fire Shader and do a quick test render. So I'll go ahead and go to the shading tab here, and I'll make sure we're in solid mode at first, and then I'm just going to choose a frame on our timeline where we have a little bit of a mixture between smoke and fire. So actually I'll go back to layout mode for this, probably around frame 30 I would think. Let's see, maybe frame 45. Yeah, something like this should be pretty good. Got a nice gasoline style look here. And you can also change your viewport shading mode in this viewport display tab here, and you can change the thickness to say 100 instead of 400. And you can get a little bit better idea of how the flames and smoke are looking. But anyways, I'll go back to our shading tab here, and I'll scroll over here to our KHAOS Fire Shader. And we've tried to make this shader as simple as possible to get really nice results with fire and smoke simulation. So as you can see here, we have your flames running through a color ramp, and you can adjust the amount of flames that kind of push through your smoke with this black slider here. So the more you move the black slider over, the more the smoke is going to kind of cover up the flames that are already seen in your simulation. And then you can also change your smoke color, the smoke density, smoke contrast, flames brightness, and the flames contrast. So I'll go ahead and go to rendered mode here, and let's see what we're getting so far. And as you can see here, this is not at all what we want for a large scale looking smoke simulation, but the good news is that we can shade this in a way for a much larger scale looking simulation. The first thing I'm going to do though is actually change the color of our ground plane here, since it's a little bit distracting. So I'll go ahead and select it, get a new material, then I'll at least make it just a very basic dark material here. Alright, so I'll select our smoke domain again, and now let's start shading our simulation. To start out, I want to bring down the smoke color a bit to something a bit darker, like so. And then we also want to increase the smoke density quite a bit. And depending on how much fuel you added to your simulation, you might not need to do this quite as much, but we didn't add very much fuel with our various operators, so we want to increase this smoke density quite a bit. So I might try something like maybe 8,000 to start off with. Now, as you can see here, it's a much denser looking explosion, but of course we want our flames to push through the smoke a bit more as well. So I'll go ahead and bring up the flames brightness to say 10. And you can see our flames pushing through the smoke quite a bit now, which is a nice look. I might increase the flames contrast a bit as well to maybe try 8. So this is going to make the brightest parts of the flames push through the smoke more. Might bring this all the way to 10 in fact. Then increase the flames brightness to say 14. I think we want the flames to be pretty bright, but we don't want them so bright that we're losing the detail in the smoke. So this is just kind of an experimentation process that you need to go through depending on your specific simulation. And you can see what I mean here with our color ramp. If I bring this black shader over, you'll notice that the smoke kind of surrounds the fire a bit more, like so. But I'll kind of leave this just kind of where it was at its default. I might bring down the flames brightness to 8 and then bring up the flames contrast to 20 so that, you know, just a lot more of the brighter spots pushing through the simulation. And then I'll bring down the smoke's contrast to 0. And of course, the more high resolution noise you use on your simulation, the more detail you're going to have to work with. So just keep that in mind when you're creating some of your renders. But I think once we add some glow to this, it's going to look pretty nice. So I got finally our smoke density at 8,000, smoke contrast at 0, flames brightness at 8, and the flames contrast at 20. Let's just see what happens when we increase the smoke contrast to say 20, just to see if we get a much thicker looking result. So yeah, you can see we get a much thicker looking smoke result when we increase the flames contrast, or the smoke contrast. I might actually increase this to maybe 30 and then bring down the actual smoke density to say 4,000. And then let's try to increase the flames brightness a bit. And now we're getting a much thicker looking explosion. Maybe bring the flames contrast up to 40. Yeah, I kind of like the way this is looking actually. Definitely a larger scale look when you increase the smoke and flames contrast. Now you'll want to check how your simulation looks at different moments as well. So you can go forward in your simulation, check the shading, and check the beginning of the simulation as well. But I think this is going to look pretty nice for a gasoline style explosion, especially once we add some glow and glare and all that good stuff to it in the compositor. One thing I might have done differently is just increase the small scale detail turbulence field, just to have a little bit more of those smaller bubbles in our simulation, but I think it's going to look pretty nice regardless. Alright, so after you adjust the KHAOS Fire Shader and get the desired result that you want, let's go ahead and add a camera and do a quick test render. So I'll go back to the layout mode here, and I'll just press Shift A, and we'll add a camera to our scene. And we'll just place this off to the side here. I'll go to our camera perspective here and just kind of frame it up here. Bring down the focal length to maybe 32, something like this. I'll also make our ground plane here a shadow catcher. Under our object properties here, I'll go to visibility and then enable the shadow catcher option. And then I'll just go to our render properties tab here. I'm going to go to sampling and just render this out with maybe 32 samples for our test render. We can also turn on adaptive sampling, and I recommend volume bounces at 4. And yeah, this should be pretty good. I'll go to our output tab here. I'm going to render this at 100%, and we can choose where we want to output our file here. So I'll go ahead and do that. Create a new folder for it here. Go ahead and accept it. And if you want, you can render out an emission pass with this as well. However, I think the bright parts of the smoke are going to be easy enough to isolate and add some glow to in the compositor, so this should be just fine. And for this specific tutorial, I'm also just going to use a PNG sequence with an alpha channel. All right, so this should be pretty good. I might adjust our lights a bit here, kind of rotate them around, so at least we have a little bit of shape on our smoke. We'll just have one as a backlight and one as kind of our main key light source. I will save our file once more here, and then I'll click on render and render image, and let's see what we get for our test render. Alright guys, so this is our test render, and it's looking pretty nice here. You can tell that because I only up-resed by 3 in this specific case, there's a little bit of lack of detail in the flames themselves, but with a little bit of glow and compositing, this should still look pretty awesome. So let's go ahead and do that really quick to conclude this tutorial. So go ahead and close our window here, and then go to the compositing tab, and I'll select the use nodes option. And what I want to do is I want to press Shift A, and we're going to add an output viewer node, and we'll just connect our explosion output to this viewer. And I'm pressing V to zoom out there. And I just want to add a few layers of glow here. So I'll press Shift A. Actually, first I'm just going to add an input RGB. I'm just going to add a color as a background. So I'll press Shift A again, add a color alpha over, and just connect this here. Actually flip it around there. There we go. And I'll bring down the color here. So we just have a little black background for us to work with. Yeah, something like that should be pretty good. And now let's add a little bit of glow to our explosion. So I'll go ahead and press Shift A. I'll add a filter glare, add this right before our alpha over node here. And we want to switch this mode to fog glow. And already that's looking pretty awesome, as you can see, but we can adjust it a bit to make it look better. I'm going to increase the detail to high, and that's looking a little nicer. And I want to bring down the threshold for what the glow is applied to something pretty low. So to enhance pretty much all the bright spots of our explosion here. So maybe 0.2 should be pretty good. Yeah, you can see the glow is being added to a lot more of the bright spots of our simulation. So that should be pretty good. I'll go ahead and duplicate this node here, and I will bring up the size this time to 7, and that's looking pretty nice. I could experiment with the threshold here as well. So I'll go ahead and press Shift D, duplicate this once more, make it a size of 9 here, and it's still super bright. Let's see, I'm going to start over here. Maybe we just want 1 glow. Let's try this. And that's not looking too bad there. So just 1 glare node, threshold at 1, size of 8, maybe make the size 9. You know, it's not bad actually. Maybe bring down the size to 7. All right, so it turns out we might just need 1 glare node here. You can add a second if you like, but this is looking pretty bright, I think. But it'll just be for a split second, so I'm going to go with this for our final result. Of course, to render out your final explosion here, we can just attach where our viewer node is going to our composite node here, and then make sure you have the right amount of samples here that you want for your render. And you can just go to render and render animation, and Blender will go through your entire timeline and export that as a PNG sequence. Anyways guys, that is it for this video. I hope it was helpful. As always, feel free to leave a comment if you have any questions or suggestions in the comment section below. Let us know what kind of videos you'd like to see next on this channel. Subscribe if you haven't already, and I will see you in the next video.